So let us start. See, in the last week we have discussed till the point of different types of structures, right? So we have discussed about cable structure, we have discussed about frame structure, we have discussed about truss structure, we have discussed about arch structure, and you understand there are differences of loads coming into those structure, not loads, internal kind of reactions, whatever is coming to those members because of some external load, they are different. Like in cable structure will be always under tension. A arch structure may be primarily it will be under compression. On the other hand, a truss structure can never come under any kind of bending. On the other and a truss structure will be always under tension and compression. That means the members of the truss will be always under tension or compression. It cannot be anything else. Okay, so if you go with that, then in such case if you notice the frame structure, if you go through, then the frame structure will have all the kinds of forces coming as internal forces. Like a frame structure may be subjected to axial tension, axial compression, bending, then shearing. All these kind of forces may come inside a frame structure. Now every structure, as you learned in your strength of material course also, that every structure needs to be supported with some kind of support, right? If a structure is not supported, then the structure will not be stable. We'll little bit later discuss about the stability of a structure and how does stability matters to a structure. That we will understand through a diagram later on, little bit later part of this lecture. Now you see, when we talk about the structure and when we talk about the idealization, when we talk about the supporting of a structure, in such case, let us try to understand the different types of supports, which already you have learned in your strength of material course, but you need to refresh these things and you need to have clear understanding about the supports in a structure. Otherwise you will not be able to do structural analysis properly. So first thing, you see that today's first thing you will understand about the support or support connections. Now you see the support connections, primarily there are three types of support connections. First one is your roller support. Second one is your pin connections or pin joints, and the third one is your fixed joint. These are the primary three support connections. All the structures generally are supported with these three types of support connections. Okay, now you see that these three types of support connections, whatever is there and whatever the structure is getting supported with, every support, if you notice, has got typical type of support reactions which will be given to the structure. So if you see a roller support, always it will allow some kind of rotation and translation. That means whenever we are talking about a roller support, then little bit larger I am making it, so you will be able to see it. See this one. So if you talk about a roller support, let's say a beam is supported on a bearing plate. The plate is just connected to anchor bolt, not the beam. The plate is connected to the anchor bolt and there is a bearing plate, and on top of that the beam is supported, and in such case you will see the support will behave something like this one is your roller support. That means a roller support whenever will come, you see, because of this rolling action, the support along with this structure the structure along with this support can move in this horizontal direction. You see, this move in this, it can move in this horizontal direction. This is what is actually roller support gives to a structure. It allows the structure to move in the horizontal direction little bit. And on the second hand, this roller support also allows some kind of rotation. Rotation means if a load comes onto the structure will be able to bend at this point. That means the structural point here will be having some kind of rotation that can be allowed by a roller support. However, you see, the roller support will not allow the structure to go down in the vertical direction, and that's why in case of roller support you will always get a reaction which will be coming from the downward direction, or the vertical reaction you will get. So this thing we will discuss little later. Now you see, next one is your pin connection. So pin connection, you see, you must have noticed this kind of structural form in railways. In railway station, if you go to a railway station, you see many kind of structures are there. These structures are basically steel structure. You see, this is called an I-beam. This is called a I-beam, because you see this looks like an eye, right? And along with this beam there is a column, and they see the column shape is also like eye, and you see this beam is attached to the column at this point, and with some connection is being made between this beam and the column. And this kind of connection, when you call, basically you see these are done with some kind of rivets or some kind of bolts. When such kind of rivets and bolts are being used, then this kind of connections will be just behaving as pin connection. And in this pin connection, you see, what will happen to this beam. This beam, you see, it will not, this support, whatever is the support given over here, that is basically the pin connection or the pin support. See, this support will not allow the beam to come out in this horizontal direction, or it will not allow it to go in this direction, as well as it will not allow this beam to come down along this vertical direction, or it will not allow this beam to go up along this column direction. So you see, what is the restraint being given over here? See, this beam will be restrained, or beam will be protected against the horizontal movement and the vertical movement. Only allowable thing will be in this case, will be just the rotation. So when you will be having rotation in this case, only you see in a pin connection rotation is allowed, and the two movements are restricted, and those two movements are vertical movement as well as the horizontal movement. So you understand what is a pin connection now. So this kind of connections will not allow the vertical movement as well as horizontal movement. However, it will allow some kind of rotation over here, Now let us come to the last kind of support joint, that is actually a fixed joint. So what is a fixed joint? You see, this kind of structure, when a column is just attached to some kind of concrete pier, and you see the base plate is being put over here. See, this kind of structure also you will be able to notice in any kind of railway station. If you go to any railway station, you see the structures erected for the shades, the structure erected for the for the foot over bridges. All these structures are steel structures, and those steel structures, if you notice very carefully or not very carefully, if you just go and look at those structures, you will be able to see this kind of structure. So, you will see that column of the steel structure will be just going inside a concrete structure, and that concrete structure, inside the concrete structure, you will see, you can observe there is a base plate, and the base plates are fixed with these bolts. So, what will happen, you see, in such kind of structure, if the support is made like this, you see this base plate or this concrete pier where this pole is attached or where this pole is fixed, it will not allow the structure to move in any direction. You get it? So, it will not allow the structure to move it in any direction. That means it will not allow to move it in this direction, it will not allow to move it in this direction, it will not allow to move it in this direction, it will not allow to move it this direction, it will not allow to move it in the downward direction, it will not allow to move it in the upward direction, it will not allow to rotate anyhow. So, all the kinds of movements are restricted, and when using a support, you are able to restrict all the kinds of rotations and translations. Such kind of supports will be called as fixed joint. Is it clear? Any question you have on this? Any question? Is this clear to everyone? Yes, very important this thing. Okay, so see, any structure, ideally if you take any structure, all the structures will be supported primarily by these three supports. One is your roller support, one is your pin support, and the other one is your fixed support. And you have now understood the difference between these three supports. Now, let us see what is the reaction criteria, what are the reaction criteria comes in this kind of supports. The next slide shows it. Okay, so let us see the next slide, this one. Okay, now you see these picture courtesies are from R.C. Hibbeler's book. Okay, so I have taken some from internet and some from R.C. Hibbeler's book. So, you will be able to see these things in R.C. Hibbeler's book also. So, you see picture wise, diagrammatically these diagrams are very easy to understand, that is why I have taken these pictures. So, you see now a beam, if you take a beam, then you see a beam can have various types of supports. So, three types of supports we have discussed. One is the roller support, one is the pin support, another one is the fixed support. So, you see if we take a beam structure, so first you take this one, So, see when a beam is supported on a roller, then what will happen? How many reactions will come? See, this beam structure is allowed to move in this direction, it is allowed to have a rotation in this direction. However, this beam structure is not allowed to move in the vertical direction. So, how many reactions will come in case of this roller support? The reaction will be only one, right? Only one, correct? And that will be the vertical direction, and that is in the y direction. So, if I take this direction, horizontal direction as x and the vertical direction as y, then only one reaction will come in this case, that is the r y. Is it clear? So, in this case you see a roller support thus will have how many degrees of freedom? It will have one single degree of freedom. Yeah. Next you go to pinned connection. So, you see this is a typical pin connection, and you see in the pin connection, what have we said? A pin connection will not allow any vertical movement as well as any horizontal movement, and it will allow some rotation. So, how many reactions will come in case of pin connection? In a pin connection, thus there will be two reactions coming. One reaction will be coming in the vertical direction and the other reaction will be coming in the horizontal direction. See, don't bother about this sign or the direction of this reaction. Okay. So whatever we take the direction during calculation, if your assumed direction, whatever direction you are assuming while starting your calculation, if your final value or the result coming with your assumed direction same sign as you have assumed, then your assumed direction is correct. If it comes with the reverse sign, so if you are assuming downward as positive and then you are calculating it and then you are getting a negative sign after the calculation, so the reaction in such case will be upward. So don't get confused about the sign and the direction. Okay. So direction will be always determined while you will be calculating. Okay. Next, the third point, you see, the third one is your fixed support. And if you see, in case of a fixed support, you notice what is happening to a fixed support. It will not allow any kind of horizontal movement. It will not allow any kind of horizontal movement. So the horizontal movement is restricted. The vertical movement is restricted. So if the horizontal movement is restricted, you are going to get a reaction in the horizontal direction. If the vertical movement is restricted, you are going to get a reaction in the vertical direction. And if you see, in case of a fixed support, as we have said in the earlier slide, what we have said, in the fixed support or a fixed joint, it will not allow any kind of rotation and it will not allow any kind of translation. So yes, so two translations are being restricted by these two reactions, right? So Rx is restricting horizontal translation, Ry is restricting your vertical translation, but who will be restricting your rotation? So if there is rotation restriction in any structure, then the rotation can be only restricted by a moment. You should be very, very carefully understanding this. A rotation will be always restricted by a moment. Rotation means what? Rotation means angular distortion of the structure. So if you do not want to have any angular distortion of the structure, the support must produce some kind of moment to restrict the rotation. So the translation will be restricted either by horizontal or vertical forces. On the other hand, your rotations will be restricted by moment. You should be very, very careful about this thing. Next, let us move to next part. And you see, whenever we see a structure, till now you have seen the structure of, only you have analyzed maybe the structure of beams and also simple supported beams or some kind of continuous beams in case of your strength of material course. Okay. Now any kind of structure, if you want to analyze, so you see the real life structure needs to be brought to a idealized form, and that idealized form, bringing the structure, real life structure into a idealized form, is called idealization of the structure. And idealization, until you do not idealization of the structure, you as a civil engineer or as a structural analyst, you will not be able to analyze the structure, because you see the real life structure may look something. However, you need to bring your structure to some idealized form. Now let us say in the next slide, let us try to understand what is idealization. So basically you see, from this idealization concept only the term modeling comes. Modeling, you have heard about this term modeling. So modeling of a structure. So basically the process of defining an ideal structure from a real structure. So you see, in any computer programming or not say computer programming, computer packages, if you want to analyze a structure, you will notice that any computer packages which is doing structural analysis and structural design, in that you will observe a term initially will be coming, that is called modeling. So, you will have to model the structure. And what is basically modeling? Modeling is nothing but the process of defining an ideal structure from a real structure. The process of defining an ideal structure from a real structure. So, basically you will be making the real structure into some form which will be ideally can be analyzed by that software program or that package, or you should be ideally be able to analyze with your assumptions and with some things, with your assumptions and with the structural mechanics basics, analyze the structure. So, you see this modeling concept is very important. Okay. Now, you see, while modeling the structure and while idealizing the structure, you see you need to remember few things. See, how do you idealize a structure from a real structure? Let us say a real structure is having, just simply assume there is a real structure, it is having 4 columns and 4 beams. Okay. So, 4 columns and 4 columns are basically joined with 4 beams. In such case, you see the columns are vertical members. So, you will have to assume that column as vertical member, and while modeling it you need to know what is the dimension of the structure. So, the dimension of the structure needs to be given, as well as you will have to model, while modeling the structure you will have to know beforehand what is the material property, of that structural element, because the material property, depending on your material property, your structural analysis and the forces will change, isn't it? Because if a structure is made up of concrete and if a structure is made up of steel, your property of modeling, the structural property for modeling will be different, because the forces being getting generated and the stresses being getting generated, internal stresses being getting generated in the structure which is made up of concrete and which is made up of steel, they will be different. Okay. So, you see, to carry out any kind of practical analysis, see, you cannot just take a snap of the building, you cannot take a photograph of the building and you can just give it to the any software program or any software package and tell them ये photograph है, इसको analyze कर दो. No, it will not be able to analyze it. You will have to model it first, and so for practical analysis it becomes necessary. It becomes necessary to idealize a structure. So, you understand now? So, idealizing a structure means you need to you will have to change the structure from real form to ideal form, and that is basically the modeling. So, idealizing a structure, let us try to understand a simple structure, how it can be idealized. You see this structure. So, see, this is a typical frame structure, right? This is a typical frame structure. See, I was talking about this frame, I was talking about the frame, this kind of structure, right? See, here you see one I beam is there, and then there is another one I beam is attached to this pin connection, and then let us say this beam, instead of this circular beam, if let us say this I beam is being attached to this pole, then what will happen? This will come something like this. So, you see what is happening? What is happening? Just a minute, just a minute, I will take a call, sir.